Let's see here. It's similar, but there's still some complications, so yeah, let's work through that. So one thing we should do is update our picture. And you might want to start a fresh piece of paper, or maybe not, I don't know. Anyway, there's your picture, good.
So this is point 1 and point 2.
Right. So now we're going to be so we want to find the probability that we're in this region.
So you want the integral from point 1 to point 2
Right?
Is it the same thing?
That's right.
So we can use
So where can we jump in our work here? All we need to change is
the last two lines.
we have to change our limits of integration. So the good news is we don't have to do this whole antiderivative thing all over again. We can still use the same antiderivative we used before. So we still have that same antiderivative. Now at this point we plugged in for n. So take your time, what should we plug in for n now?
N equals 2.
How do you know?
This says first excited.
Good, good. So I think your first instinct was to plug in n equals 1. But now that we go back and reread, this is not the first level, it's the first excited level. So as we saw before, that's n equals 2. So now this step over here, we're going to have to fix. This was where we plugged in n equals 1. So how's this going to change now that we're plugging in, or actually, this step. This is the step that we have to fix. So how's this going to change now that we're plugging in n equals 2?
Over L times x over 2 minus L over 8 pi sine of
Yeah, let's write that
4
down.
pi over L x.
So previously we plugged in 3 for n, but now we're plugging in 2 for n. So 4 times 2 is 8, and 2 times 2 is 4. Okay, and then that's going to make some adjustments down here when we go through the great big subtraction that we have to do. Now, let's see, so what did you plug in for L here?
For L or X?
For X, yeah.
Point 1 L,
And what did you plug in for L here?
point 2.
Oh, I see, here's your subtraction. Okay, that's right, so we're gonna plug in 0.1L, 0.1L. Okay. Point 1 minus 1 over 4 pi sine 0.8 plus,
-0.1.
so the only difference is that you got an 8 here and I got 4.
I have a 2 here too. Sine of
So this term is,
the 0.1.
right, now, I think you didn't distribute the 2 across
Oh,
this
yeah.
term, so 2 and 8 would give you a 4 here, right?
Mhm.
Okay. And here we've got sine 4 times 0.1 divided by 2. Maybe you're right and I'm wrong. So,
4.
where'd you get the divided by 2 here?
Cause I don't know.
That might be a mistake. So it should be sine 4 pi L times x. 4 pi L, and then x here is just 0.1, so I think it's a mistake to put in that divided by 2.
Yeah.
All you're trying to plug in there is 4 pi over L times x, so you should just plug in 0.1 L there, so there shouldn't be any 2 inside here.
So you get 0.1, 0.4.
That's what I think. 0.4, make sure you don't lose that decimal point, and this would be 0.8. Yeah, that makes sense, because after all, the only difference between these two terms is here we plugged in 0.2L, and here we plugged in 0.1L. So this term should be twice as big as this one.
Yeah, okay.
In retrospect, it might have been better if we had done the whole thing leaving the n in. Then we'd have one general expression with n, and then we could just plug in any n that we felt like, rather than having to do the whole thing over again from scratch. Anyways, this is what you have in your, now in your private paper?
Yeah.
Okay, now what?
Now you solve it.
Right, and now let's be very careful with the calculator. So let me look over your shoulder while you're doing that. In fact, start from the beginning so we can make sure we don't make a mistake.
Sine of
Oh, well, why don't we just start at the beginning on the left-hand side with 0.1?
Oh, because this is confusing to do them.
Right, now you don't really need that. Well, the problem is that if you try to do it step by step, there's too many little pieces. Yeah, the only parentheses that we need are the parentheses around the denominators. Good, so let's try to do this all in one step.
Times sine,
Mm-hmm.
0.8 pi.
Right, and that puts in the parentheses for you. Okay.
Plus, do you need parentheses here?
Nope, the only parentheses that we need are to show when there's more than one thing in the denominator or more than one thing in the numerator.